Hello everyone and welcome to this new video for the tutorial for the STM32F4. And within this part we are going to learn how to create a project using the Keil uVision. And we will see together that it's quite simple and easy. Through this tutorial for today's video, we are going to start by creating the project. We will see how from uVision we are going to create the project and then how we can select the chip, prepare the workspace and also the main file, work on adding libraries. We will see how if we do have some external libraries, we can add them. We are going to write a bit of program as we need to really have a full example that will help us later on to compile and load. Then we will set up the loading hardware. We need to load our program to the microcontroller and some hardware setup is needed. After that, we will see through the debug mode about the program that we wrote and make an exploration to see how this debug mode is working. Finally, we will check how we see the assembly code within the debug mode. And as you can see in the right side of this video, there is a microcontroller or the board that we are going to use. So the board is the STM32F4XX board, quite nice name. And the MCU itself is the STM32F407 VET6. And we need to remember this name because we will need it in the chip selection. So let's start from here and let's start create our new project. Especially in this tutorial, we are really starting from the beginning. So now we are going to start from clicking on the Keil icon and we open the program. Okay, so we do have really empty program here that we didn't even start any project. And to initiate a project, of course, just go to the tab project and here you write new vision where I would like to save. So this is the location I would like to save my project. I will call my project test, the folder where I put my project test, and we will explore it quickly. And after that, inside the test folder, we are going to call the project test. Okay, and we have quickly a window that will ask us about the chip that we would like to use. And as we checked at the beginning or in the introduction of the tutorial, the microcontroller we are going to use is the STM32F407, and after that we do have the VE. Okay, so this is the microcontroller we are going to use, and usually there is sometimes there is a multiple member of the same family for the one microcontroller, but here we are lucky, it's only one microcontroller and we can select it easily. After that, we do have the package window that comes, and we will be always using these only two packages. The first one is the core package, and this is really a core M package that will provide you the table of vector for interrupt. It's extremely important to have it, so I will be selecting it. Whatever the microcontroller, this core KIMSYS is really one of the most important library that you should add. And also we are going to add for the device, we're going to add this startup. Startup will give you the code related. So here you do have this, you can put resolve and it should be resolved quickly. So let's go resolve. Requirement differ from toolchain. That's fine. We can live with the toolchain. Okay, so even with this kind of exclamation point, we still can do our work with no issue at all. Okay, so let's go and put OK. And now we do have our project window. So what we need to do is start preparing our program so we can control the microcontroller. So first of all, in the project window that has been generated, we do have the part of this one target. And inside target, we do have the source group 1 and the packages that we just added. So as a good practice, it's better to add here the name of the microcontroller that we are going to use. So for this one is STM32F407. I think as an indication, it's enough. So maybe other people are using a different microcontroller, and by opening this and you see this indication, you will understand there's some differences and maybe the code will not be working properly. After that, from the source code, I will change the source to just source here. And here, I will be putting all my source files. So, and I will create the first one, which will be our main.c. So we go here and we just put main. So we do have here the main.c that we are going to use later on to write our main program that will be loaded in our microcontroller. However, today is a tutorial how to create a project, and we need to be practical. And we do not have enough time to program the GPIO. That will be a different session in the future tutorials. So what we are going to do now is, instead of writing the whole thing, we are going to add one of the libraries that will help us to control the microcontroller. And to do so, I already prepared the libraries, and these libraries will be added to the GitHub link, so you can just download them and follow. So we do have these 3 libraries that we are going to add. So all of them, you do have the source file and the header file. So the first library is the clock library, and this library is used to control the clock of the microcontroller, or the clock speed of the microcontroller. And we will visit it in great details in the future. And we need to add it here because the next library, sorry to jump, the time library is the library that will be used to create the delay function. So that will be using the clock library. And finally, we do have the GPIO library, and this is the library that will control the pins of the microcontroller and will ask the microcontroller to do certain stuff with the pins. So to add them, so this is our project folder, and we do have all this folder that we need for our project to copy them and add to the test here. Okay, so we do have our file added to our project. So we can go back here again, and then what we can do is go to the source, and just one of good practices. This is my practice, and I add a second group. I call it, let me close, I will call it header or headers. And I will be adding all the headers. So let's start by adding the source files. So we go here and add existing files to the group source. Okay, so, and I'll be selecting here source files. So I do have all the source files within this folder. You can select from different folders, but just to keep the whole file all together and have a clean organization, you just put them here. So you can select even with the main. The program will understand immediately that main is already part of the project, so it will not add it. And by clicking this, you can see that all these source files were added to the project. Now we can close and go to the header, do same, add existing file to group. And instead of putting C source files, we can add here the text files, whatever text, H, ink, or MD. We select those one and we put add. So let's close and check here. So of course, now you can go and check each one of these files and see how they are structured, but this is really far from the intent of this tutorial. So first of all, now we added the libraries. Let's start and by adding those libraries to the program itself. So usually a program for in C or microcontroller will have a main function, which will be an int, and we will have here main function that will be our main program function that will have a void that will get nothing, and that will be running like this. And let's add a last line here, end of line. So we do have all our program here ready. Okay, so now we have our program ready. We are going to start writing our program. And to add these libraries, even they are added to the project, so the project here is recognizing them as a part of like the whole file that it's managing. So you go here and we are going to start by adding the GPIO file. So to add the GPIO file, we just add include here and put this comma, and we are going to put gpio.h. by doing so, I'm adding to my main program the GPIO.h. I'm telling to my program, we need to use this one now, or you are able, please use the function that we have created in the GPIO source file. Okay, so this function will help us to change the status. First of all, to select which status for the pin. So we will see later on all the status of the pin that can be selected, but there is, we need to, as we would like to make a toggling of the pins, we need to select the pin as an output mode. So it can be turned on or off, and then control the status of the LED. So by doing just the code pin output set, and let's go one step behind just for as a reminder for us. So I will make it as a comment. So in our code, we do have the port A pin 8 is pin 8 is connected to the blue LED. Okay, and the port C pin 9 is connected to our red LED. Okay, so what we would like to do is put the pin output set, sorry, and that will be the pin port A pin 8, and this is coming from the GPIO library, this code. So we are going to do it, but just for you guys not being overwhelmed, this one is coming here. So by doing so, we are going to set up this port A pin 8 as an output. So let's copy the same code, and probably you guessed it. So now we need to put PC9. Just by doing so, we have set up, or we have said to our microcontroller, not yet in our actual program, that we would like to set those two pins as an output. So let's create now the phase between both. So I would like to set one as a high or on, and the other one as a low or off. So I put pin right, and this is the function that we will create in the future, and pin right for the PA8, and I would like the PA8 will be high, and after that, same for the PC9, but let's make the PC9 off. We call it, like I called it low, but later on we can control the naming. Okay, so by doing so, we created a phase. So as soon as the microcontroller will set up the stop two pins, he will set the pin A8 as high and the pin PC9 as low. Okay, and we would like to create this toggling effect forever. To do so, we are going to have an infinite loop, the while one, and inside this infinite loop, we can use a certain function called pin toggle. Just the pin will understand the state and will toggle the pin. So we are going to toggle PA8. Let's write this, and also toggling the PC9. So we just reverse their states, so PC9. Okay. After that, we need to create a certain delay. Let's take a half a second. So let's use the function delay, but to use the function delay, we need to use the time here, the time source file and header file. So same, include, let's include the time.h. And the time.h, there is a function called delay. ms is for millisecond. So let's create this delay. Okay, and then we just copy this one and we paste again. So what will happen is both pins will have their status or their state toggled and reversed. They will be at that state for half a second or 500 millisecond, and then they will reverse again. and they will wait a bit and then come back to the state. Okay, so we do have our code ready now. So let's go to the next step where we are going to compile and load. So to compile, first of all, we need to save. Let's save here, and compiling our code and build it, just click on this one. Okay, so we will have a lot of warnings that we will learn how to clean them one by one, and 0 errors. So our program will be running. And to load the code in our microcontroller, we just click on this load. So let me show you now. Let me add the picture of the microcontroller. Just 1 second. And we bring it here. And let's load it. What's happening? We do have, yeah, there is no device found. And now we are going to sit or connect our real device with this. So the device here is connected. We are not going to care about it for the moment. There is a whole tutorial about how we will manage the devices and the type of devices, but now we do have an ST-Link. Okay, so let's start this one. So our load, we couldn't load our code, and let's set up our loading hardware. To set up the loading hardware, we go here, the option for target. And we do have this a lot of you do have a lot of tabs, and you need to go to the debug one. And the debug, as I shared, the one that I do have now is the ST-Link. So you go here, the ST-Link debugger. Okay, and you should, when you click on sitting, see something here. So you do have the type here, and this is the serial number. If you don't see this, maybe you need to reconnect again your ST-Link or check it again if it works properly or not. Okay, so this is our first step. So we selected, if I put OK, now this is connected. This is great. So let's put OK, and we should be good to load our program. So let's load our program. Nothing happening. And let's try to click on the reset one and check if it works or not. So let me click. So what's happening now is we do have the thing actually reset and working well. But something is wrong, and this is through my code. What I have done is I put it here, both PA8 twice high and low, which doesn't have a lot of meaning. So let's change this one to PC9. Okay, so now we should have both pins toggling. So let's save, and we have to build again. Okay, but that's a little bit troublesome. We need to each time click on the reset button. Actually, there is a way we can avoid that. So you go again to debug, and you go to the setting here. And for that, in the flash download, you go to reset and run. And after that, this is very important, you go to the back tab and you unclick the enable. So you put OK, OK, and now let's click on the load and see what happens. So now we do have a perfect toggling situation. So now we have loaded very well and properly our code. So next step now, so we do have our code working, but sometimes it's not working. Sometimes we would like to understand what's going on. And let's to go there is this D one. So start or stop debug session. Okay, so by clicking here, so the first thing you can see is my microcontroller has stopped of moving. And that's fully normal because now your microcontroller has stopped and he's waiting for you at the first instruction here. So now the microcontroller is waiting in the first instruction here. And there's two ways to run it. You can click here. This is run mode. You just put your microcontroller running directly, or you can go on this one, step over, and go step by step through the code. Okay, so now that we confirmed this, let's explore a little bit the debug mode. And let's start. So if I click on this run here, you can see my microcontroller started. And I can immediately, and this is fantastic, I can stop my microcontroller here. You can see by clicking on the red one, so it's a real time, I can stop my, my microcontroller and debug there. And what we can see is it stopped here. So if I click here, it is now, it has toggled the PA pin. And when I click again, it will toggle the PC9. But if you would like to restart from the beginning and see what's going on, you don't need to get out from the debug mode and get back again. You can go to the reset. And by going to the reset, it opens in a different tab. You can ignore it, but you can stop here. And by running, it really starts immediately from here. Okay, so this is the steps that will help you to debug. Another very useful features, you can see what's going on the different registers or what's going on in a certain register. So here, let's go to GPIO-A, and we are controlling the pin 8. So there is a certain register, and do not worry, we are going to really go through this in so much details that will be helpful for you to understand this. And the register that controls the pin status is the ODR register or the output register. And let's take a look what will happen. So let's run here. And you can see, because we have set up previously PA8 or the port A pin 8 is high, this one is clicked like it's high, that register is high. And if I go to the next step and toggled, it become like unchecked means low. Okay, so that was a way you can visit. There is a lot of peripheral that we will be like seeing all of them through our tutorials. Okay, so let's close this one because we don't need it now. And what else? So we have seen this one, and the next thing, yeah, the assembly code. So you see here, if you're really, very well assembly, or you'd like to learn about assembly, each step in your C code is translated here into assembly, which is fantastic. For example, if I click here and I would like the start, yeah, so I can click here, but you can see how through all your assembly at the memory base, what's going on in your program. So this is one of the super good features of the Keil program. And to get out from your debugger mode, you just click on the debug and you get back to your main program. That was all for today. So if you like this program and you enjoy this content and you'd like to support, just click a like, give us a good comment, or recommend these videos. Thank you so much for following us, and see you in the next episode. Woo!